Hello, my shimmering stars. So today I, Shaurya Grover, welcome you all to this amazing platform of Physics Wallah. Students, today we are going to start with our new batch, that is NEET Selection Express. And in this batch, we are going to practice a lot of important questions as well as the previous year questions with regard to your chapter mole concept. I hope so. You all are excited because exams are approaching and you all are practicing a lot of questions. So today I'm going to bring some questions in front of you and it is a kind of a practice session. So I guess you all are excited for this. But before going on to the very first question, let me tell you one thing. If you want to lead in your life, you will feel the pain. You will feel the pain. But where there is pain, there is also a gain. So keep your spirit high. So that you can really touch the sky. So with this quote, we shall start with the very first question. So students, what I'm going to do is basically, as you all know, mole concept or the chapter, some basic concepts of chemistry, lies under the class 11th. And in this particular chapter, you shall be observing these topics. Now, what are these topics? I have brought questions from these topics as well as in this session. Okay. So the very first topic is the introduction one, where you understand about matter. Okay. The classification of matter, where you observe about what is element, what are compounds, what is mixture, what is pure mixture, pure substances. Sorry, not pure mixture. What is mixture, what is pure substances. Then you understand about the measurements in physical quantities, where you understand about the term length, time, okay, mass, temperature. And then we understand about the topic uncertainty in measurements. We further move on towards the significant figures as well as the scientific notation. After that, students, we understand about law of chemical combination and the Dalton atomic theory. In laws of chemical combination, we study about various laws such as law of multiple proportion, law of reciprocal proportion, right? And then we understand about the term atomic mass and the molecular mass, where we usually calculate atomicity. Okay. Now, moving further to the most important topic, that is mole concept. Now, why I am saying it is the most important topic, students? Because many questions are asked from the general three basic formulas. Now, what are these general three basic formulas, ma'am, that you are talking about? They are based upon number of moles. See, number of moles basically includes three major formulas. You can explain number of terms in terms of given mass and molecular mass. You can explain number of moles in terms of, volume. You can explain number of moles in terms of number of atoms, number of molecules, number of neutrons, protons, electrons. So basically there are three formulas through which we can define and explain about number of moles and on which mole concept is dependent. So this is really very important with regard to your examination point of view. Then we understand about the term concentration terms. What are concentration terms, ma'am? Concentration terms generally are molarity. Then we talk about normality, parts per million. Okay, not molecularity, sorry for that. Molarity, normality, parts per million, mole fraction. These all lie under the concentration terms. Then moving on to the next part is empirical and the molecular formula. And the last segment is the limiting reagent. So these are the topics on which questions are generally asked and I have brought up in this particular session as well. Now there are some general instructions for you people, so you have to follow them before starting to the question segment. What are the general instructions, ma'am? First of all, I shall be reading the question in front of you. I will be providing you certain time to solve that question, okay? So there is need not to hurry up because this is a kind of a practice session for you people. So you have to attempt each and every question because again I'm repeating, these questions are previous year questions as well as the most important questions that we shall be solving in this particular session. Now students, when I will be saying you, I will be telling you what are the given things provided us in the question and what we need to calculate. Moreover, what I will say is I will give you 2 to 3 minutes. So if you, after solving the question by your own, you need to match the answer with me, whether you have done your question correct or incorrect. If it is correct, it's well and good, you are going correct. But if it's not correct, then you don't have to dishearten yourself, or you don't have to feel so sad and sit at the corner and say to yourself, I cannot do this, oh my god. No, not at all. You need to stand up. You need to see where you are lacking, which is the concept you are not able to solve, you're not able to understand. So for example, if we are doing question upon, let us say, number of neutrons, okay, now you don't know how to calculate them. So what either you can do in that situation, you will sit and cry, or you can understand the topic and then solve the question. So what you can do is I will be providing you the solution as well as with the question. So no need to worry, just understand the concept, try to do the question again, because again I'm saying this is a practice session, not a final examination. So you can do as many as mistakes as you want, but you have to promise yourself that in the examination, if that mistake is repeated again, then that's not good. So you don't have to repeat the mistake, you have to learn from your mistake. Okay, so let us start with the very first question of ours. I will be reading the question in front of you. The question is, how many significant figures are present in 0.010100 into 10 raised to the power 3? A option is 7, B option is 5, C option is 3, while D option is 10. So now, how to calculate significant figures? Students, in your NCERT also you have been provided with certain rules in order to calculate significant figures. To calculate significant figures, the very basic thing that you need to understand is the non-zero digits. What are the non-zero digits? From 1 to 9. 1 to 9 are the non-zero digits. Now, what is the given thing, given question? The given statement is 0.010100 into 10 raised to the power 23. Let me tell you one basic thing over here, that whensoever you have been provided with 10 raised to the power something, that holds 0 value. So you don't have any value over here. This is being cancelled. Now you need to calculate significant figures. So you'll calculate from this basic term that is being provided to you. How you shall be calculating? Let me tell. See, first of all, the very first non-zero digit. This is a 0 digit, this is a 0 digit. The very first non-zero digit is 1. So you have to calculate from this. Now, ma'am, will you be calculating these zeros? Yes. Why? Because this is after the decimal point. So how many significant figure? 1, 2, 3, 4, 5. Total 5 significant figures are present in this particular, given question. Again repeating, the number from first non-zero digit after decimal, all number will be calculated at the right hand side position. Okay, you need to find out the very first non-zero digit. So the answer over here comes out to be option number B, that is 5. That is 5. Is it clear? So the answer comes out to be option number B. Okay students, shall we proceed to the second question of ours? Great. Great. I am being aside so that you can write the answer as well. Great. Okay, now let us see the next question of ours. I'm writing the question number over here. This is your question number first. Now moving on to the next question. What is your question number second? Let us read your question number second. Which of the following pairs illustrate the law of multiple proportion? Now you have been provided with the options. The A option is PH3HCl. B option is PbO, PbO2. C option is H2S, SO2. While D option is CuCl2, CuSO4. Now students, first of all, I am giving you 2 minutes in order to solve this questions. Kindly pause the video, solve the question by your own. Now match the answer with me. Okay, let me tell you. They have provided you the question, the law of multiple proportions. What is law of multiple proportion? Understand first of all this very basic thing. Law of multiple proportion states us that whenever we have two elements and they are forming more than one compound, so their ratio in both of these compounds shall remain same, shall remain fixed. Now that means you have to see that 2 elements should be there and they are forming more than 2 compounds or 2 compounds. Okay, so 2 elements should be there, not more than 2. So if I see the very first A option, I have in pH3 I have phosphorus and hydrogen. In HCl I have hydrogen and Cl. So how many total elements? Ma'am, 1 phosphorus, hydrogen and then chlorine. 3 elements. So they won't be able to follow law of multiple proportion. In order to follow law of multiple proportion, you need to identify 2 elements who are making compounds. Now moving on to the next one, B part, we have Pb and oxygen. We have Pb and oxygen again. Now how many elements, ma'am? 2 elements. Now Pb and oxygen are forming PbO also. They are forming PbO2 also. So this is what is law of multiple proportion. When you have 2 elements and they are making more than 1 compound, or I can say they are making 2 compounds or more than that. So our correct answer shall be option number B. Answer will be option number B. If you look up to the option number C, we have H2S, SO2. H2S, here we have hydrogen, sulfur, and here we have oxygen, again 3 elements. So this is also incorrect. Now looking up to the D part, we have Cu, we have Cl, and we have sulfur. We also have oxygen. So 4 elements. So this is also wrong. Hence the answer comes out to be option number B. Is it clear? Kindly write it down so that we can move on to the third question of ours. Now yes, let us look up to the third question, my dear students. What is the third question? Third question is 3.011 into 10 raised to the power 2 atoms of an element weighs 1.15 gram. The atomic mass of the element is, you need to tell the atomic mass for this particular element. Now let me tell you, here 22 will come. Kindly correct this. Here 22 will come. Yes, okay. 10 raised to the power 22 atoms. Now I am writing the given part over here, then we are going to solve the question. What is given situation over here? Ma'am, they have given us number of atoms of a particular element. So what is given to you as per the question? They have provided you number of atoms. They have provided you number of atoms. How much? 3.011 into 10 raised to the power 22. Now they have given you the mass. The given mass is being provided you of that atom. So given mass I am writing with GM. This is your given mass. How much, ma'am? 1.15 grams. 1.15 grams. The atomic mass you need to calculate. That means you need to calculate the molecular mass, or you can say the atomic mass. It's one of the same thing. I represent it with mm or with m. This is what you need to calculate. Because we are talking about an element, so we say atomic mass. If you are talking about a molecule, you shall be saying molecular mass. So atomic mass we need to calculate, right? Now these are the given situations. How we need to solve this question? Let us look up over here. Let us do the solution section over here. See, basically, we have been provided with number of atoms. Now, when I was initially starting this particular session, I told you one basic thing, that number of moles revolve around 3 general formulas. Now, 3 general formulas are either number of atoms or volume, or I would say your given mass by molecular mass. So, we basically know that number of moles which are represented by small n is equivalent to given mass by molecular mass. Also, number of moles is equivalent to number of atoms divided by Avogadro number. So these are the 2 formulas for number of moles. There is also one more formula that is based upon volume. That is volume divided by 22.4 liters, right? So we are going to use these 2 formulas because we need to calculate what? We need to calculate this. Okay, and we have been provided with number of atoms. So if I correlate these 2 formulas, what will be my new formula? Ma'am, my new formula will be given mass by molecular mass is equivalent to number of atoms divided by Avogadro number, right? Now just see, given mass is provided to us, that is 1.15 grams, divided by molecular mass, ma'am, we need to calculate, is equivalent to number of atoms is again provided to us, that is 3.011 into 10 raised to the power 22, divided by Na. What is Na value? Avogadro's number. What is its value? 6.022 into 10 raised to the power 23. Now 3 2s is 6. If we'll divide it, it will be divided on the table of 2. Now when you're going to take this above, okay, what you are going to do is you are going to divide it. 10 will come over here. So what is the current situation? It is 1.15 divided by molecular formula is equivalent to 1 by 20. So now we are going to cross multiply this particular thing. See, molecular mass comes out to be 1.15, which I can write it as 115 divided by 100 because I am taking the decimal down, into 20. So the 0 gets cancelled and 2 5s are 10. Now when I am dividing, it comes out to be 23. So the mass comes out to be 23 grams. Mass comes out to be what? 23 grams. Hence, if I look up to the options, I have A option as 10, B option as 2.3, C option as 35.5 and D option as 23. So our D option shall be the correct answer. Answer comes out to be option number D. Is it clear to you? I am getting a side so that you can write down this particular question. Shall we proceed to question number 4th? Shall we start with the question number 4th? Okay. Now comes your question number 4th. What is your question 4th? Which of the following contains the largest number of atoms? Here you need to tell which of the following has the largest number of atoms. You have been provided with A option 11 grams of CO2, B option 4 grams of H2, C option 5 grams of NH3, while D option 8 grams of SO2. Now you should know again the very basic formulas, the general formulas is to calculate about number of moles. Number of moles is given mass upon molecular mass. Also you can write number of moles as number of atoms divided by Avogadro number, right? Basically, see, here you use number of molecules. Let me tell you one thing. Number of molecules into number of, if you are calculating number of atoms, so number of atoms is number of molecules into total number of atoms. Let me write it over here again. Let me write this over here again. See, number of moles is basically number of molecules by Na. This is the general formula. But if you need to calculate number of atoms, so basically how you are going to write it down, I shall show you with the question itself. I shall show you with the question itself. See, let us see the A part. A part is 11 grams of CO2. This is A part. That means this is given mass. Given mass is 11 grams. What is molecular mass for CO2? For CO2 you can calculate 1 carbon. So 1 into carbon mass. 2 oxygen. So 2 into oxygen mass. 1 into carbon mass is 12. 2 into oxygen mass is 16. So this comes out to be 12 plus 32. That is 44 grams. Yes. So how you will calculate number of moles? Ma'am, number of moles comes out to be given mass upon molecular mass. What is given mass? Given mass is 11. Molecular mass is 44. Number of moles is 1 by 4. Now, you need to calculate what? You need to calculate number of atoms. So, number of atoms generally is number of molecules. Understand this very basic thing. Number of molecules into Na into total number of atoms. Okay. Now, what is number of moles? It is 1 by 4 into Na into what are total number of atoms? CO2, 1 carbon, 2 oxygen. How many atoms? 3 atoms. How many atoms? 3 atoms. So, this comes out to be 3 by 4 Na. Now, moving to the B part. Now, let us calculate for the B part itself. For B part, it is 4 grams of H2. Given mass is what? 4 grams. Molecular mass for H2, 2 into hydrogen mass, 1. That is 2. Right? Number of moles is given mass upon molecular mass. Given mass is 4, molecular mass is 2. So, this comes out to be 2. Now, you need to calculate number of atoms. Number of atom is number of molecules into number of total number of atoms. Now, 2 into Na. This comes out to be 4 Na. Right? Now, let us see the next part, the C part. C part is 5 grams of NH3. Given mass is 5. Molecular mass NH3. Nitrogen is 14. hydrogen is 1, 3 hydrogen, so it comes out to be 17. This is number of moles. Now how many atoms? 4 atoms, total 1 nitrogen, 3 hydrogen, 4 into Na. So this comes out to be 1 point something something into Na. Now option number D, it is 8 grams of SO2. Given mass upon molecular mass, SO2, sulfur mass is 32, O2, that is 16 into 2 is again 32, that comes out to be 64. Right? Now it is 1 by 8 number of moles into Na into total atoms is 3. So basically if they want to calculate the largest number, don't write the value of Na, just look over in all the options. The total number comes out to be here, that is 4Na, that is option number B. So option number B is going to be your right answer. Answer comes out to be option number B. Answer comes out to be option number B. If they have asked you about number of molecules, then there is no need to multiply into 2, into 3, into 3. No need to multiply. But when they're asking about number of atoms, then you need to multiply total number of atoms. Great. Shall we proceed to the next question? Okay. Now comes the question number 5. What is question number 5? The number of molecules in 4.25 grams of ammonia is approximately how much? Sorry. Very sorry. A option is 3.5 into 10 raised to the power 23. B option is 0.5 into 10 raised to the power 23. C option is 2.5 into 10 raised to the power 23. While D is 1.5 into 10 raised to the power 23. Over here they have provided you students with given mass and they are asking the number of molecules. Now I am giving you 2 minutes in order to solve the question, then you can match with me. Right? I am writing the given values over here. What is given to us in this particular question? Given to us is given mass. Given mass, which I am representing by GM, is about 4.25 grams. Moreover, they have given you another thing, that is ammonia, that is NH3. So you can calculate molecular mass. Ammonia is NH3. So 1 into how many atoms of nitrogen? 1. So 1 into nitrogen mass. How many atoms of hydrogen? 3. So 3 into hydrogen mass. Nitrogen mass is 14. So 1 into 14 plus 3 into hydrogen mass is 1. This comes out to be how much? 17 grams. So the molecular mass comes out to be 17 grams. What they have asked you? They have asked you number of molecules, right? How to calculate number of molecules? Number of moles is equivalent to number of molecules divided by Avogadro number. Moreover, number of moles is equal to given mass upon molecular mass. Yes, so you can correlate both of these formulas. If you correlate both of these formulas, what shall be the new formula? New formula shall be number of molecules divided by Na is equivalent to given mass upon molecular mass. Number of molecules you need to calculate as per the question is equivalent to what? Given mass upon molecular mass into Na. This will be our new formula. Na will go over there. Now just look up to this particular statement over here. Number of molecules shall be equivalent to given mass. Given mass is ma'am 4.25 grams. Divided by molecular mass is ma'am 17. Into Na. Na is 6.022. Na is 6.022 into 10 raised to the power 23. Now when you're going to solve this, let us take this decimal down over here. 4.25, I can write 425 by 100. So this 17 into 25 is about 425, okay. So that means 25 into 6.022 into 10 raised to the power 15 is our correct answer. 25 into 6.022 into 10 raised to the power 23. Now if you are going to take it approx value over here, if we are going to solve it as an approximate value, this comes out to be 1.5 into 10 raised to the power 23. That means your option number D is going to be the correct answer. So answer comes out to be option number D. Answer comes out to be option number D. I want you all to write it down so that we can move on to our next question. Shall we proceed to the next question of ours? Great. Shall we proceed if you have written the students? Now we are going to do the question number 6th. Yes. Okay. Now comes out to our next question, that is question number 6th. Question 6 says 4.4 gram of an unknown gas occupies 2.24 liters of volume at STP. The gas may be A option N2O, B option CO. C option is CO2 while D option is A and C both. Now over here in this particular question, what they have given us is given mass. Given mass is 4.4 grams, okay, and it occupies volume of about 2.24 liters. So the gas we need to find out. That means, see, we don't have molecular mass, so we need to calculate molecular mass. How can we calculate? We know number of moles is given mass upon molecular mass. And if I want to define number of moles in terms of volume, what will be my formula? My formula shall be volume divided by 22.4 liters, right? So, see, basically, if I correlate both of these formulas, it shall be given mass upon molecular mass is equivalent to volume by 22.4. Now, what is given mass? Given mass is basically 4.4 grams. Molecular mass, we don't know. But volume, we know over here. Volume is 2.24 liters divided by 22.4. Yes? Yes? Okay, now what we are going to do is we are going to solve it out. See, is basically if we need to calculate molecular mass, it comes out to be 4.4 into 22.4 divided by 2.24. Now let us take all the decimals over here. What it shall be, molecular mass is 4.4 can be written as 44 by 10 into 22.4. I can write again 10 below. Then we have 2.24. That means 100 will go like this. So this is basically 100 gets cancelled. 224 gets cancelled. We get molecular mass as 44 grams. So now with the help of this molecular mass, we can compare the given options. Let us see the options now. In A option, it is N2O. Let us calculate its molecular mass. How many nitrogen? 2. So 2 into nitrogen mass. How many oxygen? 1. 1 into oxygen mass. Now what is the mass of nitrogen? 14. So 2 into 14 plus 1 into oxygen mass is 16. So 2 into 14 is 28 plus 16. This comes out to be what? 44 grams. Is it same? Yes. That means A option is correct. Let us see more options. B option is CO. Now what is how many carbon? 1. So 1 into carbon mass plus 1 into oxygen mass. Carbon mass is 12 and oxygen mass is 16. So this is 12 plus 16. This comes out to be 28. That means B option is incorrect. Now moving on to the C part. That is CO2. Again, how many carbon? 1 carbon. So 1 into carbon mass. How many oxygen? 2. So 2 into oxygen mass. 1 into carbon mass is 12 plus 2 into oxygen mass is 16. So this is 12 plus 32. That comes out to be 44 grams. So again 44 grams. It's matching. That means option number C is also correct. So if A and C both are correct, our answer will be option number D. Answer comes out to be option number D. Answer comes out to be option number D. I want you all to write it down so that we can move on to question number 7th. I want you all to write it down so that we can move on to question number 7th. Let us see next question of ours. Okay. Now question number 7 says that the amount of sugar C12H22O11 required to prepare 2 liter of its 0.1 molar aqueous solution is A option is 68.4 grams, B option is 17.1 gram, C option is 34.2 gram while D is 136.8 grams. Okay, right? What they have provided us, amount of sugar you need to tell. That means you need to find out the given mass. Molecular mass you can tell with the formula. It is C12H22O11. So what will be the molecular mass? How many carbon? Ma'am, 12. 12 into carbon mass. How many hydrogen? 22. 22 into hydrogen mass. How many oxygen? 11. So 11 into oxygen mass. Now 12 into carbon mass is 12 plus 22 into hydrogen mass is 1 plus 11 into oxygen mass is 16. So it shall be 144 plus 22 plus it is 176, right? So it is basically 166 plus 176, which comes out to be 342 grams. Yes, this is molecular mass. Moreover, they have given you volume, that is 2 liters. Also they have given you molarity. Molarity is being provided to you 0.1 molar. That means you need to find out given mass. How you will calculate? With the help of the formula of molarity. What is the formula of molarity? Molarity, ma'am, basically is number of moles of solute divided by volume of solution in liters. Yes. Now molarity is being provided to you as 0.1 molar. Number of moles can be written as given mass upon molecular mass into volume. Now see, this is 0.1 is equivalent to given mass is being you need to calculate, divided by molecular mass you have just calculated 342 into what is volume, it is 2. Now we shall cross multiply. Given mass comes out to be 0.1 into 2 into 342. Now when I'm multiplying, it's 486 and decimal is there 0.1, so it is 68.4 grams. It comes out to be 68.4 grams. So which of the following options is going to be correct? That is option number A is our correct answer. Option number A shall be our correct answer. Is it clear to you people? Is it clear to you? Can we move on to the next question of ours if it is clear to you, students? Now comes out to be our question number 8. Let us read the question number 8. Question number 8 says that 8 grams of NaOH is dissolved in 18 grams of water. Mole fraction of NaOH in the solution and molality of the solution respectively are. Now understand this. Now just understand this. Over here they have given you this much gram of NaOH. Yes. So given mass of NaOH is being provided to you, that is 8 grams. What is the molecular mass of NaOH? Can you calculate? Yes, ma'am. How many Na? 1 Na. How many oxygen? 1 oxygen. How many hydrogen? 1 hydrogen. So, what is the mass of Na? 23. What is the mass of oxygen? 16. For hydrogen, 1. So, it is 23 plus 16 plus 1. It comes out to be 40 grams. Yes? Yes? Right. Okay. Now, can you calculate number of moles? Yes. Of NaOH. Number of moles is given mass upon molecular mass. Given mass is 8 and molecular mass is 40. So, this comes out to be 1 by 5 moles. Yes. These are number of moles of NaOH. Yes, ma'am. Yes. Great. Now, similarly, can you calculate for water? Given mass is being provided to you. Yes. See, given mass of water, they have given you 18 grams. What is molecular mass of water? How many hydrogen? 2. So 2 into hydrogen mass. How many oxygen? 1. So 1 into oxygen mass. This comes out to be 2 into 1 plus 1 into 16. That means 18 grams. Now what is number of moles of water? It shall be given mass by molecular mass. Given mass is 18. Molecular mass is also 18. So number of moles comes out to be 1. Yes? Okay, ma'am. It comes out to be 1. Now they are asking you to calculate mole fraction of NaOH. Mole fraction of NaOH. Mole fraction of NaOH. Mole fraction of NaOH is equivalent to number of moles of NaOH divided by total number of moles, that is of NaOH as well as of water. That is of NaOH as well as of whom? Of water. Yes. Now just see. Number of moles of NaOH is basically 1 by 5 divided by total moles. Number of moles of NaOH again 1 by 5. For water it is 1. This comes out to be 1 by 5 divided by 5. We are going to take LCM. So 5 plus 1 is 6. So 5 gets cancelled. Mole fraction comes out to be 1 by 6. It comes out to be what? 1 by 6. So when you're going to solve it, it comes out to be 0.167. Mole fraction of NaOH comes out to be 0.167. If you look up to the options, here you have 0.2, here you have 0.2. That means either it is option number B or D. Now comes the second part. They are asking you to calculate what? Molality. Molality. Molality is represented by small m. What is the formula? The formula for molality is number of moles of solute divided by mass of solvent in kg. Okay. Now, number of moles of what? Solute of NaOH. Number of moles of solute is 1 by 5. Divided by mass of solvent. What is solvent? Water. What is solvent? Water. Understand this. What is solvent, ma'am? Water is the solvent, ma'am. So, it is given in grams. So, you need to find in kg. So, you will multiply it by 1000. Yes, yes. So, it shall be 1 by 5 into 18 into 1000. You will multiply it. It shall be 200. So, when you are going to solve it out, what will be your answer, my dear students? I want you all to calculate the answer for this. What shall be the answer? Yes, students. It comes out to be 11.11. That means option number B is going to be your correct answer. option number B shall be your correct answer. Is it clear? Kindly write it down, students, so that we can move on to our question number 9th. Kindly write it down so that we can move on to question number 9th. Yes. Now comes question number 9th. Question 9th is, for the following reaction, the mass of water produced from 445 grams of this much is. Now understand the question over here. What they have given you in this particular question. This is the general reaction, and they are asking you the mass of water. They have given you this gram, 445 gram. Understand, 2 of this reactant is producing 110 molecules of water. 2C57H110O6 is producing 110 of water. 2 is producing 110 of water. 2 molecules are producing 110. 1 molecule will produce 110 divided by 2. That comes out to be 55 moles. 55 moles of water. 55 moles of water. Understand? Now, here they have given you mass. Here they have given mass. If I ask you what will be the molecular mass, you can calculate. It shall be 57 into carbon mass plus 110 into hydrogen mass plus 6 into oxygen mass. So it shall be 57 into carbon mass is 12 plus 110 into hydrogen mass is 1 plus 6 into oxygen mass is what? It is 16. It is what? It is 16, students. When you're going to solve it out, it comes out to be 890 grams. Right? 890 grams. So now, if this is the molecular mass, this is the given mass. Number of moles shall be given mass upon molecular mass. The given mass is 445 divided by 890. 445, 2's is 890. So it basically number of moles comes out to be 1 by 2. So for 2 molecules producing 110, one will produce this much. So how much will half moles produce? Half will produce 55 into 1 by 2 moles of water. These are number of moles of water. Number of moles of water. But they are asking to calculate mass of water. They are asking us to calculate mass of water. So number of moles is equal to given mass upon molecular mass. Number of moles is 55 divided by 2 is equivalent to given mass we need to calculate. But we know the molecular mass of water is 18. So can we cross multiply it? When we are going to cross multiply it, given mass comes out to be 55 into 18 by 2. 2 9s are 18. So 9 into this. Now we are going to multiply. 495 grams. This comes out to be 495 grams. Hence, our option number A is going to be the correct answer. Hence, our option number A is going to be the correct answer. Is it clear to you, people? Is it clear to you all? Now, we shall move on to our next question. But before that, I want you all to write it down. Before that, I want you all to write it down. This we have done with question number 9th. Now, let us look up to the question number 10th. So students, I hope so you have done this question. Now let us move on to our next question. Now let us see what is the next question. The next question is, in this reaction, 2 aluminium plus 3 by 2 O2 gives Al2O3, right? Okay. So 9 grams of aluminium will react with how much O2? This is our question. What are the given options? Let us read that also. A option is 6 grams O2. B option is 8 grams O2. C option is 9 grams O2, while D option over here is 4 grams O2. Now, how we need to solve these questions? Again, this is a kind of a stoichiometric question, okay? So, initially, what we need to do is, ma'am, we need to write the reaction first of all. What is the reaction given to us? The reaction is 2 aluminium. Let me write it over here, okay? Let me write it over here. 2 Al plus 3 by 2 O2, okay? Now, it gives us what? It gives us, ma'am, Al2O3. Yes, it is a balanced equation provided to us. They have given us 9 grams of Al. Now, this is provided to us as 9 grams. 9 grams of aluminium. And what we need to find out, students? We need to find out how much O2 is being produced. And also, we need to find out in grams. That means we need to find out the given mass. Okay, so how we have to solve this question? See, basically 2 aluminium is reacting with 3 by 2 O2. Is it clear? Yes, ma'am. 2 aluminium is reacting with 3 by 2 O2. So if I ask you, 1 aluminium is reacting with how much O2? 1 aluminium will react with how much? It will be 3 by 2 into 1 by 2. Because if 2 is reacting with this much, then 1 will react with 1 by 2. Yes? Yes, ma'am. Okay. Now, they have provided us with the given mass of aluminium. With the what? With, ma'am, given mass of aluminium. They have given us 9 grams of aluminium. Now, what we can do is, can we calculate number of moles? Yes, ma'am. So, number of moles, students, basically is given mass upon molecular mass. What is the given mass? 9 grams. What is the molecular mass now? If we are talking about an element, it has an atomic mass. If we are talking about a molecule, it has a molecular mass. So, aluminium has an atomic mass of 27. Yes, ma'am. Of 27. So, what shall we get? We'll get 1 by 3 moles. Now, if one aluminium is forming this much moles of O2. So, 1 by 3 moles of aluminium will form how much O2 moles? It will be 3 by 2 into 1 by 2 into what? Into 1 by 3 moles of O2. So, this 3 gets cancelled. We shall get 1 by 4 moles of O2 are being produced. Yes, ma'am. Great. But the answer is in grams. The answer is in grams, and also it is given mass. So, what will be our correct answer? We know that, see, we know that, I am putting an arrow over here so that you won't get confused, okay? Number of moles is given mass upon molecular mass. Number of moles came out to be 1 by 4 is equivalent to given mass we need to calculate divided by molecular mass. Now, molecular mass of whom? For O2. O2 molecular mass, 2 into oxygen mass. 2 into oxygen mass is 16. So, this shall came out to be, ma'am, what? 32. 32. When you cross multiply, the given mass comes out to be 8 gram. It came out to be what? 8 gram. So, what shall be our answer? What shall be our answer? Ma'am, option number B will be our correct answer. Answer shall be option number B. Is it clear to you, people? Shall we move on to our next question, students, if you have done this? Yes, great. Okay. Now, let us look up to the next question that we have. The next question is the percentage composition of carbon by mole in methane is. You need to calculate the percentage composition of carbon in methane. Now, understand. I'm giving you 2 minutes. First of all, you need to solve the question by yourself. When I am saying I'm giving you 2 minutes, you need to pause the video and solve the question first by your own self. Then you need to match your answer with me. Yes? Okay. Now comes percentage composition of a particular element. Percentage composition of a particular element is basically the mass of that component. The mass of that component divided by total mass. Into what, ma'am? Into, ma'am, 100. Very simple. So, if I am talking about only carbon in CH4, how many carbon? 1 only. So, 1 into carbon mass is 12. Yes? 1 into carbon mass is what? 1 into carbon mass is what? It is 12. Yes? Now let us see. It is basically divided by how much? It is basically divided by how much? Students, I am giving you 1 minute. Write it down the molecular mass. Write down the molecular mass very fast, very fast. Be very fast in solving such questions. Now, I will tell you one twist over here. I'll tell you one twist over here, but I want you all to solve it by your own. Let yourself try this question, because there is a twist in this question. Okay. Now, what you are going to do, you are going to calculate the percentage composition of that component based upon the mass. But if you will see over here, if you will see in the question, they have given you carbon is present by mole. Carbon is present by mole. That means here we are not applying the mass concept. Here we are applying the mole concept. So basically, if carbon is present by mole, that means carbon is present in 1 mole, and also carbon is 1 over here. So total number of moles, if I talk about 4 hydrogen and 1 carbon, 5 moles. That means if I am going to define percentage composition over here in terms of by mole concept, I would say carbon's composition divided by total's composition. If carbon composition is 1 mole, total composition will be 1 plus 4, that is 5 into what? Into 100. So now when you're going to solve it, it came out to be what? 20%. It came out to be what? 20%. So the answer comes out to be option number D. So the answer comes out to be what? It comes out to be, ma'am, option number D. Is it clear to you, people? Now students, shall we move on to the next part? Yes, shall we move on to the next part? Tell me very fast. Tell me very fast. Can we move on to the next question? Okay, I shall read the next question for you all. Kindly write the question very fast. So students, don't get confused in this question. In this question, they have given you percentage composition of carbon by mole. Okay, they have told carbon by mole. That means that is mole percentage composition. That is not mass percentage composition. So don't get confused in such kinds of questions. Now, let us see the next question. The percentage of nitrogen in urea. Now they have not told you by mole or anything. That means directly you have to apply the mass over there, right? So now basically, what is the formula of urea? It is NH2CONH2. Okay, this is the formula of urea. Yes, ma'am. Okay, now can we calculate the molecular mass? How many nitrogen? Total of 2 nitrogen. So 2 into nitrogen mass plus how many hydrogen? Total 4 hydrogen. So 4 into hydrogen mass plus how many carbon? 1 into carbon mass plus 1 into oxygen mass. That means 2 into nitrogen mass is 14 plus 4 into hydrogen mass is 1 plus 1 into carbon mass is 12 and 1 into oxygen mass is 16. So this comes out to be 28 plus 4 plus 12 plus 16. That means this comes out to be 32 plus 28. That means it is 64 grams. Can let me check it overall again. Yes. Sorry. So this is basically your 32 plus 28. That means it comes out to be 60. It comes out to be 60. Yes, students. I guess you all have calculated the molecular mass. Yes, okay. Now how to solve this question? Just let us see over here. The percentage of nitrogen in urea. That means the mass of urea, the mass of nitrogen divided by mass of urea, the total mass of the molecule in 200. Now, how many nitrogen, ma'am? 2 nitrogen. So 2 into nitrogen mass divided by mass of urea 60 into what? 100. Now, what is the mass of nitrogen, ma'am? 14. Divided by 60 into what? 100. Yes, yes, ma'am. This is, sorry, we can also simplify it further. This is 2. 3s are 6. So, basically, it is 140 by 3. That means if I am going to solve it out, it will go on the table of 4. Right? So, 12, 20, 46.6%. That means option number B is going to be our correct answer. Option number B is going to be our correct answer. Yes, students, can we proceed to the next question of R? If you have done this question, shall we proceed? Great. I guess you all have written this part. Okay. Now, moving on to the next question, let me read the next question for you people. 10 gram of hydrogen and 64 grams of oxygen were filled in a steel vessel and exploded. The amount of water produced in this reaction will be, A option is 3 moles, B is 4 moles, C is 1 mole, while D is 2 mole. Students, till then I'll write the question number which I've forgotten to write. So this was your question number 10th. This was your question number 11th. Now here came question number 12th. And now is your question number 13th. Okay. So 10 gram of hydrogen and 64 grams of oxygen were filled in a steel vessel and exploded. Amount of water produced in this reaction will be what? Will be what? Now just understand this over here. Hydrogen, when reacted with oxygen, produced water. Let us balance this equation first of all. In the reactant side 2 hydrogen, in the product side 2 hydrogen, in the reactant side 2 oxygen, while in the product side only 1 oxygen. That means we are going to multiply it with 2. Now hydrogen became 4, so we are going to multiply it with 2. This is the balanced equation. Now what they provided is 10 grams of hydrogen is reacting with 64 grams of oxygen. You need to find out amount of water produced. So for this case, first of all, you need to calculate what, ma'am? You need to calculate the limiting reagent. The limiting reagent, see, initially if they have given you values for only one reactant, then you can directly solve the questions as we used to do. this much moles contain this much and so on. But if they have given you the values of two reactants, then for that case you need to calculate the value for limiting reagent, students. Now in the case of limiting reagent, if I talk about, first of all, see how to calculate limiting reagent. You need to check out number of moles by stoichiometric coefficient value. If it is low, then it is a limiting reagent. What is stoichiometric coefficient? The numbers that are written in front of them. Here one will be there when nothing is written, right? So first of all, calculate number of moles in this case. Given mass is 10 grams. Molecular mass for H2. For one hydrogen it is 1, for 2 it will be 2. So number of moles came out to be 5. So number of moles by stoichiometric coefficient is 2. So it comes out to be 2.5. The value is 2.5. Not 8, it is 2.5. Now over here, given mass is 64 by molecular mass. For oxygen it is 16. For 2 oxygen it will be 32. So this comes out to be 2. 2 divided by stoichiometry is 1. So here its value comes out to be 2. Which is the lower value? Ma'am, this 2 is the lower value. That means this is our what? Limiting reagent. O2 is our limiting reagent. That means O2 is going to help us to calculate the mass for H2O. Now see, one O2 is forming how many H2O? Ma'am, one O2 molecule is giving 2 H2O molecule. Now, what is the number of moles we calculated? 2. So 2 moles of O2 will form how many moles of H2O? It will be 2 into 2. That means 4 moles of H2O will be produced. Yes? Yes, ma'am. Now you have calculated number of moles. What is the formula? Number of moles, ma'am, is equivalent to given mass upon molecular mass. Number of moles is 4. So given mass by molecular mass for water, again it is 18. So given mass comes out to be what? 18 into 4. That means 72 grams. That means 72 grams. Now let us see the question. In this particular question, they're asking in terms of moles. So moles came out to be how many? 4 moles. Answer in terms of moles comes out to be 4 moles. In terms of grams, it comes out to be 72 grams. Yes? So our answer comes out to be option number B. Answer comes out to be option number B. Shall we move on to our next question? Yes? Okay. Now let us see the next question of ours. The next question is the simplest formula of the compound containing, this is question number 14th. Okay, the question is the simplest formula of the compound containing 50% of an element X, okay, with atomic number 10 and 50% of element Y with atomic mass, here atomic mass will come, not atomic number, kindly correct it, okay. Atomic mass 20 by weight is. Now see what they have given you. Now this is empirical formula, molecular formula concept. First of all, you will write here element. You will write here element. Then you will write the percentage composition. Then you will write the atomic mass. Yes? Yes. Now then percentage composition divided by atomic mass. Then you will write the simplest ratio. Now let us see how to do this question. You have been given with two elements X and Y. For X they have given you percentage composition as 50. For Y again they have given you as 50. Atomic mass for X is 10 and for Y is 20. So percentage divided by atomic mass, percentage is 50, atomic mass is 10. So it comes out to be 5. Similarly, percentage is 50% by atomic mass is 20. So this comes out to be 2.5. Now what you have to do is you have to divide the lower value by both of them. The lower value is 2.5, so you will divide it. It will be like 5 divided by 2.5. Similarly, 2.5 divided by 2.5. So 2.5 when divided by 2.5 is 1, right? And when you are going to solve it, it comes out to be what? It comes out to be 2. Yes. 5 by 2.5, 10 will go above, so it will be 2. Yes. Now see, now it is 2, so it will come like x2. How much is y? Y is 1. So the molecular formula comes out to be x2y1, x2y1. Hence our option number B is going to be the correct answer. Hence our option number B is going to be the correct answer. Hence our option number B is the correct answer. I am giving you a minute in order to write it down so that we can move on to our next question, students. Yes, students, shall we proceed to the next question of ours? Great. Now comes your next question. Let us read the question for you people. A gas is molecular formula CHN. If vapor density of the gas is 39, what should be the formula of the compound? A option given to is C3H3, B is given as C4H4, C is given as C2H2, while D is given as C6H6. Now see over here how we have to solve this question. A gas has a molecular formula CHN. Yes, okay. And its vapor density is 39. Is what? Is 39. Vapor density comes out to be what, ma'am? 39. Now students, what is the relationship between vapor density and molecular mass? You should know that molecular mass, ma'am, is equivalent to 2 into vapor density. So 2 into vapor density is 39. This comes out to be what? 78 grams. This comes out to be what? 78 grams. This is the molecular mass. This is the general formula. Now if you have to write it, it is 78 grams. What is the mass of carbon? It is 1 into 12 plus how many hydrogen? 1 into 1 hydrogen. N is written like this, is equivalent to 78, is equivalent to 78. Now what is this basic thing that I have done over here? This is 12 plus 1 is 13. So 13 into N is equivalent to 78. N comes out to be what? 78 divided by 13. 78 divided by 13, it comes out to be what, ma'am? 6. So the N value comes out to be 6. That means here if you'll put the value as 6, so it will be what? It will be C6H6. It will be what? C6H6. It will be what? It will be C6H6. Hence our compound comes out to be option number D. Hence our compound comes out to be option number D. Is it clear to you people? Is it clear to you people? Can we move on to the next question of ours? Shall we move on to the next question of ours? Okay. Now let us read the next question. The next question is basically the number of significant figures in 60.001 is. The number of significant figures in 60.001 is. Now see the first non-zero digit. 6 is the first non-zero digit. Hence everything will be calculated because it's a decimal. So 1, 2, 3, 4 and 5. So the answer comes out to be option number A, that is 5. The answer comes out to be option number A, that is 5, because it holds 5 significant figures. Because it holds 5 significant figures. I hope so these questions now you are feeling comfortable and you are able to solve these kinds of questions as well. Yes? Yes, students? Can we move on to the next question of ours if you have written this? Shall we move on to the next question of ours? Tell me fast. Okay, now comes your next question. The question says that if the law of conservation of mass was to hold true, if the law of conservation of mass was to hold true, then 20.8 grams of BaCl2 on reaction with 9.8 grams of H2SO4 will produce 7.3 grams of HCl and dash BaSO4. That means here you need to calculate the mass of BaSO4. Now students, hint, they have provided you law of conservation of mass. What is law of conservation of mass? The total mass of reactant is equivalent to the total mass of product. What does it states? That the total mass of reactant is equivalent to the total mass of the product. Yes. So basically let us write the reaction first of all. They are saying BaCl2 on reaction with H2SO4 is producing HCl and BaSO4 So BaCl2 basically has mass of 20.8 grams. H2SO4 has 9.8 grams and it is producing 7.3 grams, and they are asking this mass. So total mass of reactant is equivalent to the total mass of product. Now let us write it, let us add it. Let us consider it as X. Okay, so what shall be the value if you are adding it out? It is 30.6. This, when you will take it over here, you will subtract it. So this comes out to be the value of X, which comes out to be how much? It comes out to be 20.3 grams. It comes out to be 3 grams. So the answer comes out to be option number B. The answer comes out to be option number B. Was it a simple question and easy question? So now see, if you have studied the concept, the question becomes easy for you people. Now comes your next question, students. Let us read the question. The question is 5 moles of AB2 weighs about 125 into 10 raised to the power minus 3 kg, and 10 moles of A2B2 weighs about 300 into 10 raised to the power minus 3 kg. The molar mass of A Ma, and the molar mass of B, Mb in kg moles are. Now let us see the question. They have given you moles and they have given you the given mass value. For whom? For AB2. So we know that number of moles is basically given mass upon molecular mass. This I am talking about AB2. Okay. So see, number of moles basically is 5 moles. Given mass is given to you as 125 into 10 raised to the power minus 3 divided by molecular mass. Now can we calculate molecular mass for AB2? Molecular mass comes out to be what? 125 into 10 raised to the power minus 3 divided by 5. So this is basically, this comes out to be 25 into 10 raised to the power minus 3. Similarly, can we calculate the molecular mass for the next molecule? Yes. For now, A2B2. For now, A2B2. Again, number of moles is equivalent to given mass upon molecular mass. Number of moles over here is 10 moles is equivalent to given mass is provided to you as 300 into 10 raised to the power minus 3 divided by molecular mass you need to calculate. So when you are going to solve it, this comes out to be, molecular mass comes out to be 30 into 10 raised to the power minus 3. Now see students, a very different concept, a new concept that you should know over here. See, the molecular mass for AB2 comes out to be what? 25 into 10 raised to the power minus 3. Can we write it as 1 into A mass plus 2 into B mass? Yes ma'am. Yes. Okay. From here, can I calculate the value of 2B? 2B comes out to be what? 25 into 10 raised to the power minus 3 minus A. This is my new equation. Yes. Now from the second equation, see, from this basically A to B2. Can I write as like this? 2 into A mass plus 2 into B mass is equivalent to the molecular mass. What is the molecular mass? 30 into 10 raised to the power minus 3. And can I equate the 2B value over here? Yes ma'am. So this is basically 2A plus, what is the value of 2B? 25 into 10 raised to the power minus 3 minus A is equivalent to 30 into 10 raised to the power minus 3. 2A minus A is A. You will take this over there. You will get what? 5 into 10 raised to the power minus 3. So A came out to be what? 5 into 10 raised to the power minus 3. So A value we have already calculated. A value we have already calculated. Now we will look up to the value of B. B value we can already equate over here. See, it will be 2B is equivalent to 25 into 10 raised to the power minus 3 minus A. A is 5 into 5 into 5 into 10 raised to the power minus 3. So this is basically 20 into 10 raised to the power minus 3. This is 2B. So B comes out to be what? 10 into 10 raised to the power minus 3. A came out to be 5 into 10 raised to the power minus 3. B came out to be this. So option number C is going to be our correct answer. Option number C is going to be our correct answer. I'm giving you a minute in order to write this question down. I'm giving you a minute in order to write this question out so that we can move on to our next part. Shall we proceed to the next question of ours? Shall we proceed? Okay. Now comes your next question. The question says that the atomic mass of sodium is 23. The number of moles in 46 grams of sodium will be. Very simple thing they have given you. Molecular mass they have given you. Given mass they have provided you. Number of moles they are asking. Number of moles, students, is given mass upon molecular mass. Given mass basically is 46 grams they have provided you. And the molecular mass for sodium is 23. So this comes out to be what? 2 moles. This comes out to be what? 2 moles. Hence the answer is going to be what, ma'am? Answer is going to be option number B. Answer is going to be option number B. Very simple. Very easy. Okay, let us see the next question of ours. The next question basically is that which of the following contains least number of molecules? Which of the following contains least number of molecules? Now let us see one by one. If I talk about option number A. If I talk about option number A, it is basically 4.4 grams of CO2. So given mass is provided to you. Given mass is what, ma'am? 4.4 grams. Molecular mass will be how much? For 1 into carbon mass plus 2 into oxygen mass. Carbon mass is 12 plus oxygen mass is 16. 16 into 2 is 32. So this is 44. What will be number of moles? It will be given mass upon molecular mass. Given mass is given to you as 4.4 and molecular mass is 44. So that comes out to be 1 by 10. Now this is number of moles, but they are asking number of molecules. So number of molecules basically, students, will be number of moles into Na. Into what? Into Na. So this is 1 by 10 Na. Number of molecules comes out to be what? 1 by 10 into Na. Na is Avogadro number. Now similarly we can calculate for the B part. Similarly, can we calculate for the B part? See, for the B part, it is given mass is 3.4 divided by molecular mass. For NH3, for ammonia, 14 for nitrogen, 1 for hydrogen, 3 hydrogen, so 17. This is number of moles. Number of moles comes out to be what? 2. It will be 2 divided by 10, that is 1 by 5. 1 by 5 is number of moles. So, when you are going to multiply number of moles with Avogadro number, it comes out to be your number of molecules. It comes out to be your number of molecules. So this is 1 by 5 Na. Yes? Yes, ma'am. Now comes C option. Now comes the C part. In C part, 1.6 grams given mass by molecular mass of CH4 is again 16. So this comes out to be 1 by 10. This comes out to be 1 by 10. So when you are multiplying number of moles as Avogadro number, this is number of molecules. Yes. Now comes the D option. Given mass is 3.2 by molecular mass of SO2. For sulfur 32, for O2 again 32 plus 32, 64. This is 1 by 10 and this when you will divide it will be this. So it will be 1 by 20 moles. When you are multiplying moles with Avogadro number, it is molecules. So if they are asking the least number, when you are going to solve it out, the option number D has the least number of molecules. Hence, our answer came out to be option number D. Students, in questions, in your examination, in your NEET examination, there is no need to write the value of Na and start solving it. No. If you are observing that all of the options contains Na value in it, so you can just directly write Na and just compare them because it is a kind of comparison. Okay, so it will save your time. Now let us see the next question of ours. Now the next question states that which of the following contains, now I guess this is repeated question. Okay, yeah, it is repeated twice. So this is already done. Already done. Same question, 20. So I am going to cut this slide, okay, over here. Okay, now comes your next question. If 32 grams of O2 contains 6.022 into 10 raised to the power 23 molecules at NTP, then 32 grams of sulfur under same conditions will contain how many molecules? So basically, see, let us calculate number of moles over here. Given mass by molecular mass. Given mass by molecular mass. Given mass is how much? 32. Molecular mass for O2, 2 into oxygen mass, 2 into 16 is again 32. Number of moles came out to be what? 1. 1. So number of moles is equivalent to number of molecules by Na. Yes, okay. So now let us see over here also. 32 grams of sulfur. 32 divided by sulfur mass is also what? 32. So again 1 moles. If 1 mole, students, over here is containing this much molecules, so 1 moles over here will contain same number of molecules. Hence our answer is going to be option number A. Hence our answer is going to be option number A. Because 1 moles over here is containing this much molecules. Moles you have calculated. So with this 1 mole, it will contain same number of molecules. Hence answer comes out to be option number A. Shall we move on to our next question? Can we move on to our next question? Okay, students. Now comes your next question. Let us see the next question. Question is, the molarity of a solution obtained by mixing 750 ml of 0.5 molar HCl with 250 ml of 2 molar HCl will be. Now this is a question of total molarity. This is a question of total molarity of a mixture. How you have to calculate? For total molarity, you can write M1V1 plus M2V2 divided by V1 plus V2 divided by what? V1 plus V2. Yes, students. So what is M1 V1 over here? This is the value of V1, volume 1. This is molarity M1. Now you are mixing it with V2 and this is your M2. So how you are going to solve it? M1. M1 is, ma'am, what? 0.5 into V1. Ma'am, V1 is 750 plus M2. M2 is, ma'am, 2 into V2 is, ma'am, 250 divided by total volume. Total volume 750 plus 250 comes out to be what, ma'am? 1000. So this, when you're going to solve it, 10 can cancel. Okay. 875 by 100, so it will be 8.75. Sorry, by 1000. It is by 1000. So our answer comes out to be 0.875. The total molarity of the mixture comes out to be 0.875 molar. Hence option number D is going to be our correct answer. Hence option number D is going to be our correct answer. Yes? Okay. Now let us move on to the next question. If you have written this, shall we proceed to the next question, students? Okay. Now comes your next question. The next question states that in a gaseous reaction of the type, you have been provided with a certain reaction. You have been given this certain reaction, that is AA plus BB gives CC plus DD, which is wrong. A option is A liters of A combines with B liters of B to give C and D. B option is A moles of A combines with B mole of B to give C and D. C option is A grams of A combined with B grams of B to give C and D, while D is A molecules of A combined with B molecules of B to give C and D. Now see over here. Whenever we're talking about these things, do you remember in the previous question also we were calculating moles? So this is A moles is combining with B moles of B to give C and D. So our option number B is going to be our correct answer. Option number B is going to be our correct answer, direct answer. If you have done the limiting reagent concept. Now comes your next question. The next question is, how much oxygen is required for complete combustion of 560 grams of ethene? How much oxygen is required for complete combustion of 560 grams of ethene? Ethene basically C2H4. Ethene basically C2H4. Combustion refers to as when you are reacting it with O2 and it is forming CO2 in water. This is what is combustion. This is what is combustion. Yes? Okay, ma'am. So let us balance this. 2 carbon, here is 1 carbon, so 2 will come. 4 hydrogen, so here is 2 hydrogen, so 2 will come. Now, 4 oxygen plus 2 oxygen is 6 oxygen. Here is 2 written, so 3 will come, 6 oxygen. It is a balanced equation. They are saying that it is 560 grams of ethene present. And you need to calculate what? You need to calculate how much oxygen is required. See, 1 ethene is reacting with 3O2. 1 ethene reacting with 3O2. So, here, this is the given mass. What? Calculate number of moles. Given mass is 560 by molecular mass. For 2 carbons, so 2 into 12, 1 hydrogen mass is 1, 4 hydrogen, so 4. It will be 24 plus 4, 28. So you'll calculate, it comes out to be 20 moles. So see, if 1 C2H4 is reacting with 3O2, so 20 moles will react with how much? 3 into 20? That means 60 moles. That means 60 moles. Now this is moles. This is ma'am moles. But here you have to find answers in grams and kgs. That means mole is equivalent to given mass upon molecular mass. Number of moles is 60. Given mass you don't know, but molecular mass for O2 you know. O2. For 1 oxygen 16, for 2 it will be 32. Now you are going to cross multiply, it will be 32 into 60. So this comes out to be 1980. But do remember, this is in grams. This is in grams. Answer is asked in kg. Answer is asked in what? Kg. Yes? Sorry, one thing. It is 1920. Okay, now answer is asked in kg. So you shall divide it by 1000. Hence answer comes out to be 1.92 kg. So option number B will be your correct answer. Option number B will be your correct answer. Is it clear? I'll write it over here again. Okay, it is 1920 grams. Yes? Yes? Shall we proceed to the next question of ours? Shall we proceed to the next question of ours if you have done this? Okay, students. Okay, students. The next question basically is 2.76 grams of silver carbonate on being strongly heated yield a residue weighing what? I want you all to write the equation by your own. First of all, I want you all to write this equation by your, then I will tell you how to solve it out. Shall we do, students? Silver carbonate Ag2CO3. When you are heating it, it will give you Ag, it will give you CO2, it will give you O2. This is our reaction, okay? First of all, balance this reaction. How many Ag? 2 Ag. So 2 will come over here. How many carbon? 1 carbon. How many oxygen? 3. Over here, how many oxygen? 4. So can we write it like 1 by 2? So it is 1 oxygen plus 2, 3. And here is 3. Balanced. Now they are saying 2.76 grams of this on being strongly heated will yield a residue. Residue, the leftover. That means Ag mass you need to calculate. So it's very simple. See, it's very simple. 1 Ag2O3, Ag2CO3 is giving 2 Ag. So now, can we calculate number of moles? Number of moles is given mass, that is 2.76 divided by molecular mass. Divided by what? Molecular mass. Now let me tell you, the molecular mass comes out to be 276. So this comes out to be 1 by 100 moles. Now, if 1 is giving 2, so 1 by 100 will give how many moles? 1 by 100 Ag2CO3. 1 by 100 Ag2CO3 will give how many? 2 into 1 by 100 Ag. These are the moles. These are the moles. Now, you know that formula. Number of moles is what? Given mass upon molecular mass. Number of moles is 2 into 1 by 100 is equal to given mass. By molecular mass of Ag is 108. Cross multiply them. Given mass comes out to be 2 into 108 by 100. So this comes out to be 2.16 grams. This comes out to be option number A as our correct answer. This comes out to be option number A as our correct answer. I am giving you a minute in order to write it down. I am giving you a minute in order to write it down. Shall we proceed to the next question of ours? Yes, students. Yes, students. Okay. Okay. The next question states that what is the mass percentage of oxygen in ethanol? What is the mass percentage of oxygen in ethanol? Ethanol basically C2H5OH. Okay. So again, mass percentage they are asking, and mass percentage, talking about mass. So it will be mass of oxygen divided by total mass into 100. So how many oxygen? 1. 1 into oxygen mass is 16. By total mass, how many carbon? 2. 2 into carbon mass plus how many hydrogen? 6. Total of 6. 6 into hydrogen mass plus 1 into oxygen mass into 100. So 16 divided by 2 into carbon mass is 12 plus 6 into hydrogen mass is 1. 1 into oxygen mass is 16 into 100. So this is 16 divided by 24 plus 6 plus 16 into 100. So this comes out to be what? 16 by 46 into 100. Yes, students, 16 by 46 into 100. Is it clear to you people? So this comes out to be 34.73%. That is your option number D is going to be your correct answer. Option number D shall be your correct answer. Is it clear? Can we move on to the next question if you have done this? Shall we move on to the next question if you have done this? Next question states that in a reaction container, 100 grams of hydrogen and 100 grams of Cl2 are mixed for the formation of HCl gas. What is the limiting reagent and how much HCl is formed in the reaction? Okay. So let us write the reaction first of all. Reaction is H2 plus Cl2 is forming what? HCl. Okay, and they're saying 100 grams of H2 is reacting with 100 grams of Cl2. Okay, and the formation of is done of HCl. How much HCl is formed? How much of HCl is formed over here? So see, first of all, balance it out. 2 hydrogen, 1 hydrogen, so you shall multiply it as balanced equation. Now, first of all, we'll calculate the value of a limiting reagent. What is the limiting reagent? How to calculate limiting reagent, ma'am? Number of moles by stoichiometry coefficient. If its value is low, it is limiting reagent. So over here, number of moles. Given mass is 100. By molecular mass for H2 will be 2. It will be 50. Over here, given mass is 100. By molecular mass, 2 into chlorine mass. Chlorine mass is 35.5. 2 into that is 71. 2 into that is 71. So you are going to calculate, it will be the lower value. Hence, Cl2 is the limiting reagent. Hence, Cl2 is the limiting reagent because it has a low value. So if Cl2 is the limiting reagent, these two options are get cancelled. Now, the next thing. They are asking how much HCl is being produced. So see, if 1 Cl2 is producing 2 HCl, so this much moles will produce how many? It will be 100 by 71 will produce into 2. This much moles of HCl. But here they're asking in grams, so these are number of moles. 100 by 71 into 2, this is number of moles. Yes, is equivalent to given mass upon molecular mass. Molecular mass for HCl. HCl, hydrogen is 1, Cl is 35.5, so it is 36.5. So you'll calculate given mass 100 into 2 by 71 into 36.5. Now see, now it is very simple. When you're solving such kinds of questions, there is no need to solve the question in detail. Now see the options. Here it is 73, here it is 104.28. See, here if you're going to solve it out, students, it is going to come in decimal value. Hence our option number second is going to be the correct answer, because it is not the correct answer, is not 73 grams. Yes, so our answer comes out to be option number B. Can we move on to the next question if you have done this? If you have written this, shall we move on to the next question of ours? Yes, students. Okay. Now comes your next question. Next question is, a compound contains 38.8% of carbon, 16% of hydrogen and 45.2% of nitrogen. The empirical name of the compound is, A option is CH3NH2, B option is CH3CN, C option is C2H5CN, while D is CH2NH2. So see over here, what we need to do is, first of all write element, then write percentage composition, then write mass, then write percentage divided by mass, and then write simplest formula or simplest ratio. Element basically is carbon, hydrogen, nitrogen. Carbon percentage is given to us as 38.8. Hydrogen is given as 16, and for nitrogen it is 45.2, right? Mass for carbon is 12, for hydrogen is 1, for nitrogen is 14, right? Now percentage divided by mass, percentage is what? 38.8 divided by mass is 12. Percentage is what? 16 divided by mass is 1. Percentage is 45.2 divided by mass is 14. Divided by mass is what? 14, students. Now what you are going to do, ma'am? Now we are going to divide them. Now when you're going to divide them, it is going to come out to be 3.2. This comes out to be 3.2. This comes out to be 16 by 1 is 16. This also comes out to be 3.2. Simplest ratio is you are going to divide with the smallest number. Smallest number is 3.2. So 3.2 divided by 3.2 comes out to be 1. 16 divided by 3.2. It comes out to be 10 by 2. That means 5. Now 3.2 divided by 3.2 is 1. Now see. C is 1. H is 5. And N is 1. So now check everyone. C is 1. H is 3 plus 2, 5. N is 1. Option number A is our correct answer. If you check the C option, there are C3. So this is wrong. Here if you look up to, here N is 2. So this is wrong. Here you see C is 2. So this is wrong. So option number A is our correct answer. Option number A comes out to be our correct answer. Is it clear? Is it clear? Okay, now let us see the next question of ours. The next question states that, which has the maximum number of molecules among the following? Which has the maximum number of molecules among the following? So again, first of all, calculate number of moles. Number of moles is given mass upon molecular mass for CO2. 12 plus 32, 44. Number of moles is 1. When you multiply number of moles with Avogadro number, it comes out to be number of molecules. So number of molecules is 1 into Na. Over here, B option, if we talk about, given mass is what? Given mass is 48. Molecular mass for O3. For oxygen it is 16. 3 into 16 is 48 again. So this comes out to be what? 1. So this also comes out to be 1 Na as number of molecules. 1 Na as number of molecules. Yes. C option. Given mass is 8. Molecular mass for H2 will be 2. So this comes out to be 4. 4 into Na is number of molecules. Yes. Okay. Here, given mass is 64. By molecular mass for SO2 is also 64. So this comes out to be 1 into Na. 1 into what? Na. So maximum number of molecules is present in option number C, that is 8 grams of H2. So answer comes out to be option number C. Answer comes out to be your what? Option number C. Can we move on to the next question? Okay. Okay, one more question, students, which I want for you people. Question number 30th. Let us write over here. Calculate number of neutrons in 12 into 10 raised to the power 23 atoms of O178. This is your question. Very simple question. Very simple. First of all, calculate neutrons. The number of atoms they have given you. They have already provided you with number of atoms. That is 12 into 10 raised to the power 23. So, total number of neutrons, what will be total number of neutrons? Total number of neutrons in O178. See, this is basically what your atomic mass represented by A. This is what your Z, atomic number. So, if I say, see, in a neutral species, what happens in a neutral species? In a neutral species, atomic number and number of protons are same, so number of protons is 8. And we know that mass number is number of protons plus neutrons. Okay, neutrons plus protons. Mass number is 17. Number of neutrons you need to calculate. Protons is 8. So number of neutrons comes out to be what? 9. Right? So total number of neutrons is 9. Number of atoms is provided to you. They are saying calculate number of neutrons. So number of neutrons formula will be what? Number of atoms into total number of neutrons. That means 9 into 12 into 10 raised to the power 23. So can you write 12 as 9 into 6 into 6 into 10 raised to the power 23? And you know 6 into 10 raised to the power 23 is what? Na. Is what? Na. It is what? Na. So basically you can solve this question in such a way. Yes, 9 into 10 raised to the power 23. So you can solve this question in such a way. You can write directly as Na. You can write directly it as Na. Yes, is it clear? Okay, I guess there is a yes into 54. So such kinds of questions can be asked in your examination, students. Such kinds of questions can be asked in your examination as well while talking about the term neutrons, protons. Okay, so I guess now this is clear to you people. I guess now this is clear to you, right? One of the question was generally asked in a good book regard to this question only. So you can open this in terms of Na. Okay. So these are number of atoms being provided to you. You'll multiply it with neutrons. You'll get total number of neutrons. You'll get number of neutrons. Okay. Is it clear to you people? Yes, my dear students. So we are going to end our very first session over here. I hope so. This session was very, very beneficial for you and you were able to practice all the questions with regard to the chapter mole concept. We are going to bring each and every chapter for you people, but very important thing which I would say to you people is that kindly practice as much as possible. See, if you were able to sorry, if you were able to solve the questions, then it is well and good. Keep going. But if you're able if you were not able to solve the questions, no need to worry, students. You still have time. Okay, so you can learn from your mistakes rather than crying. Learn from your mistakes. Okay, and try to solve it again, the question which you were not able to do so. Okay, so now we shall meet in the next lecture with more questions based upon the next chapter. And yes, if you feel any of the question you have any doubt, you can write in the comment section. We shall take in the upcoming classes and solve the question again for you people. So thank you so much, students. Keep learning, keep smiling. Have a good day.